Welcome back to my video series on the dependency inversion principle. In the last 4 videos, we discussed the DIP from a design and implementation point of view, and in this final video, I want to check out with you how following the DIP impacts the software architecture of our solutions. Again, let's start with the essential 2 messages the DIP tells you. Program against abstractions instead of concrete types. And tailor these abstractions to the clients. Do not include implementation details in them. With this in mind, let's have a look at the traditional layered architecture. In this diagram, you can see the typical 3 layers that are normally utilized in it. The user interface, the business logic, and the data access layer. Right beside these 3 vertically stacked layers is the infrastructure layer. So let's quickly discuss what kind of types you can find in each of these layers. The infrastructure layer mostly contains library and/or framework code, that is, reusable components like the .NET framework, object relational mappers, UI frameworks, web frameworks, and the like. The most important part of this layer is, in my opinion, its ability to manage external systems, like talking to databases, to the file system, to the network using different protocols, or to the user. The data access layer then holds solution-specific types that are related to storing and loading from, for example, a database or the file system. These can be classes that map to tables for an object relational mapper, custom SQL queries and DML commands, or stored procedures. On top of that sits the business logic, containing the core code that does the actual heavy lifting that a company needs. This might be, for example, the processing of a shopping cart if you have an online shop, or the processing of incoming and outgoing flights at an airport. The code here really depicts the field, or domain, you're actually working in and that you want to automate. On the highest level sits the user interface. I think it is very clear that in there you can find views and UI related logic. Now, is this architecture conformant to the dependency inversion principle? No, not really, I would say. Have a look at the dependency arrows between the different layers. The user interface has a direct dependency on the business layer, and the business layer on the data access layer. This means that the data access layer is the most important solution-specific layer here, because without it, the 2 other layers cannot run. Imagine that the data access layer is tightly coupled to a certain database. This means the database is the central element in our solution. In every manual or automated test, you need it to be there, and this takes a lot of flexibility and swiftness from the developer when extending and testing the system. But what is the real problem here? It is this dependency arrow here between the business and the data access layer, because it violates the second statement of the DIP. Abstractions should not depend upon details. But if you reference the data access layer assembly from your business assembly, then you take in all these intrinsic details of data access, especially if you do not make your load and save calls through abstractions. A practical example here. If you have an existing database, and you let Entity Framework create model classes for you that you maybe modify through the designer. And then take a reference on this assembly in your business class library and program directly against DB context and the model classes. This is really the violation of the DIP I was just talking about. So let's fix this problem by making the business layer the core of our solution by inverting this dependency. Dependency inversion. Huh? You get it? This means that the business assembly does not depend on anything else except for framework or library code. But how do you save or load data, or do network communication, or execute any other boundary code from within your business layer? The answer is that you define interfaces in this layer that your core logic programs against, and then take a dependency on the core in your other projects and implement the interfaces there. Finally, you can compose all necessary objects in a composition route wherever you host your code, be it in a client application or in a service running on a server. If you have a look at this diagram now, you can see that the business layer is in the center of all things and completely independent of all other stuff. Even the framework reference can be inverted if you define the corresponding interfaces and implement them in adapter classes that encapsulate the framework or library you want to use. You can use the core in any situation easily, be it automated testing, building up software demonstrators that show parts of the system, or even the whole production system where all comes together, if you like. If you draw concentric circles into this diagram, you'll see that we arrived at a very different software architecture, and this architecture was described before by various famous software developers. Alistair Cockburn calls it a hexagonal architecture. Geoffrey Palermo calls it the onion architecture. And Warren Vernon calls it the ports and adapters architecture. All these authors describe their architecture slightly differently, but this difference is very small in my opinion, and the essential theme is the same. The business layer is the core of the architecture and independent of all other layers. The other layers are grouped around the core and can enhance it by implementing the core's interfaces. Mark Seemann wrote an interesting blog article about that, and you can find the link to it in the info box below. I hope you've seen that a layered architecture is not the way to go if you want to structure your object-oriented code according to the dependency inversion principle. In fact, I want to encourage you to opt for a ports and adapters architecture most of the time because I believe it's the most flexible one currently documented. I would just go for the layered architecture if I was under a lot of time pressure. But then again, I wouldn't write clean, well-structured code in this situation, and this means that I have to clean up this mess later usually. And this leads me right to the last question of this video series. When should I put no abstraction between client and supplier code? We've talked about interfaces and abstract base classes a lot in the last videos, and I hope you saw that overall they make your code more flexible. But making every call polymorphic results in a lot of interfaces or abstract base classes that make our code less maintainable. So are there some places where tight coupling makes more sense than loose coupling? I have no definite answer here, but I can give you some guidance how I approach this problem. I often use a technique called domain-driven design, which describes the decomposition of a problem domain into several aggregates with entities and value types. An aggregate itself is a cluster of associated objects that we treat as a unit for the purpose of data changes. If you want to learn more about domain-driven design, then please check out Eric Evans' awesome book with the same title and Warren Vernon's book, Implementing Domain-Driven Design. You can find the links in the info box under this video. However, within an aggregate, I often couple my classes tightly because they reside on the same level of abstraction and belong to the same problem area. Also, I usually do not create an interface for value objects. These are immutable objects that normally have no important functionality associated with them, but simply represent a single value, for example, a color or a currency. In general, I would say if two classes solve a problem in the same domain, and if they reside on the same level of abstraction, you can consider leaving out the abstraction between them. But if in doubt, I would advise you to rather go for the abstraction between client and supplier, just because it is a little more flexible in the future. And this is it for this video series. I hope you learned a lot about decoupling client from supplier code, about programming against abstractions, and composing your object graphs with confidence. So thanks for watching this video, and I hope to see you again in the next one. Bye!